Hello, today we're doing problem 9.20, and this problem asks us to draw the products for each of these reactions and indicate the stereochemistry around any stereocenters. So the first problem we look at is this one right here, A, and we see that we have an alcohol group, a hydrocarbon, and a proton and deuterium, which is an isotope of proton of a hydrogen. So this is what we consider a primary alcohol, and if you remember, primary alcohols follow an SN2 concerted mechanism. So that means that the nucleophile will attack and the leaving group will leave all in one step. And because of this, we get an inversion of stereochemistry. So if we were S around the chiral center, we would then become R. If we were R, we would get S. If you remember, secondary and tertiary alcohols, they typically follow an SN1 mechanism in which the leaving group will leave first, giving us a carbocation intermediate. And because carbocations are sp2, they are planar, they're flat. So our nucleophile can attack with equal probability from the top and from the bottom, giving us a racemic mixture of both R and S stereo products. So if we start with this problem here, we see that we have I, and obviously this will dissociate to H plus and I minus being the nucleophile, OH being the leaving group. So we can just show an SN2 concerted one-step nucleophilic backside attack, making a bond. When you make a bond, you must break a bond. So our leaving group will leave. And now we need to show the inversion of stereochemistry. Now here's the trick. In order to invert your stereochemistry to whatever it is, if you want to go from R to S or S to R, all you need to do is change the positions of two molecules on your compound. So for example, in this starting material, our hydroxide is going into the page while this proton is coming out of the page. So that means in order to invert my stereochemistry, the hydrogen must go into the page while now my new group, iodine, must come out of the page. So by just flipping the positions of two products, of two substituents, you will invert your stereochemistry. So let me show you that. So here we have something that is going counterclockwise. So this is S. And this one, we have something that is going clockwise, which is R. So we see by just flipping the two positions of these two substituents, we converted and we inverted the stereochemistry. Now let's move over to problem B. Problem B, we see that this is a tertiary alcohol. So we note that this alcohol is going to be protonated by this hydrogen. Why? Because this hydrogen is actually dissociated to H plus and Br minus, giving us an intermediate that looks like this. Protonated water, which will then spontaneously fall off to neutralize itself and give us our carbocation intermediate, specifically a tertiary carbocation intermediate. And as you see here, because it is sp2, I don't draw stereochemistry anymore because it's planar. So now our nucleophile Br minus can attack with equal probability from the top and from the bottom, 50-50 chance. So this will create a racemic mixture, meaning 50% R, 50% S product. However, this product is actually going to be achiral. So I don't actually have to draw any stereochemistry, but in order to show both the 50% R and 50% product all in one structure, what you can draw is squiggly lines. So that means that it is both a wedge, meaning coming out of the page, and a dash going into the page. But because this molecule has an internal plane of symmetry, it is actually achiral. So now let's go over to the last problem. Similarly, before we have a tertiary alcohol. So if I use the oxygen being electronegative, has nucleophilic properties, it will pick up this proton to form our protonated water. OH2 protonated, which can then spontaneously fall off to give us our carbocation intermediate, tertiary carbocation, at which point our nucleophile Cl- can then attack with equal chance from the top and from the bottom, giving us two products. And remember the trick, if you change the position of any two substituents, you will change its stereochemistry. So this methyl group in this one is going out of the page while chlorine is going into the page. And then the other stereochemistry product is going to have chlorine now coming out of the page and the methyl group going into the page. And now we have a 50-50 racemic mixture of these products. So optically, it is going to be inactive. However, we do get two unique stereo products from this reaction.